This means to say, in case of adiabatic processes, there is no supply of outside energy, system will definitely do work. But if it is doing work, work is done by the system, what happens to you? Your energy decreases. At 5 o'clock, you will be in the tired state. Why? Sir, I have not taken breakfast, I have not taken lunch, but still I am doing system. What was the energy when you came to the classroom? 500 joules. Morning. And next, what happens when I'm talking about the 5 p.m.? Sir, my energy is supposed to be 100 joules. What happened? Decreased. Why it is decreased, sir? It has been used 400 to 100 or 500 to 100. This loss is utilized somewhere. What is that? Work. Therefore, adiabatic expansion always causing cooling effect, right? Temperature decreases. Okay, nice. Now, this is first law of thermodynamics. I have taken all the possible cases. What I have done? I have written the possible cases of first law: isochoric, isothermal, isobaric, adiabatic. 4 processes I have done. Now come to the next section. Next section, again I am coming to work. Already I have given you graphical representation of work. I have given you expression for work minus P external delta V, because in thermodynamics we talk about mechanical work. Mechanical content in the, mechanical, I am here in Rajmandi, so I have to talk about in Telugu for them. Mechanical work means what? So mechanical work means we are having expansion, piston is going up, piston is going down. Therefore, expansion work and compression. Formula you know, how to calculate you know, but see the method. What is now we are having 4 marks question. If you are saying work is a path function, what is the meaning of paths? Go back to previous graphs. Sir, you have taken straight line, you have taken inclined line, you have taken semicircle line, you have taken cyclic process, you have taken anti-clockwise, clockwise. All they are called paths. Yes. But still we have so many paths available. Roll number 1 stood up. Sir, I want to do a job isothermally. Is it not a path? Yes. Roll number 2 stand up. Sir, I want to do the job of expansion adiabatically. I want to do the job by maintaining constant pressure, constant temperature, right? Q is equal to 0. One fellow stand up. No. I want to do the process reversibly. One fellow say, I want to do the process irreversibly. Yes, all these are called paths. Isothermal reversible expansion, a path. Isothermal irreversible expansion, another path. Adiabatic reversible expansion, a path. Adiabatic irreversible expansion path. Expansion I have discussed 4 cases. Why don't you talk about compression? Yes, sir. We have 4 more cases available with respect to compression. This means to say that these are also classified as paths. If you are saying they are the path, naturally you will have a doubt. Sir, if it is the path, how to calculate the amount of work done? Yes. For that purpose, today we are enjoying a topic, work, a path function. If it is a path function, goes on changing paths, I'll give you the formula. You say, sir, I want to do isothermal expansion, I'll give you a expression. You are saying, sir, I want to do isothermal irreversible, I'll give another formula for you. Okay, let us go one by one and try to understand in a proper way. Derivation part by PC doctors, you can ignore it, but MPC students, be careful. You should be very strong in the derivative part, derivation part, and also conclusions. Okay, now, first one, isothermal irreversible expansion. Take care of the headings properly. Isothermal means constant temperature. Expansion means increase in volume. Piston should move up. Irreversible means delta P should be large. Yes, delta P. We have said on that day, if suppose, for example, delta P is large, then the process is supposed to be irreversible process. Chaliye. How to proceed? Very simple, sir. I don't know all these things. I know the formula W is equal to minus P external delta V. Basic thing we have to take up and you have to develop. Basic thing you have to take up, that we have to develop. That development called ranking. Okay. For example, now in that case, again I am talking about one more situation. Come on, go back. Irreversible. Listen please carefully. All right. We have a beautiful discussion here. Irreversible. What is the meaning of that? Roll number 1. Go back to that example. 100 marbles on the piston. I call roll number 1. Come on, do work of expansion. He came and he removed all 100 marbles in one step. Then I said the piston will bump up. Very sudden expansion takes place. That is a beautiful example of irreversible process. Now, if suppose he is removing all 100 marbles, what is he doing actually? He's doing outside pressure 0. Let us don't consider the pressure of atmosphere. We are doing job in vacuum. Okay, we are having vacuum, and in the vacuum, in the lab, we are having a piston, cylindrical vessel, gas is available. On the piston, we are having 100 marbles. I call roll number 1 and he removed all 100 marbles. What happens? There is no outside pressure. If there is no outside pressure, listen carefully. If there is no outside pressure, piston will bump up, but work done is 0. Sir, piston is moving up. Piston is moving up. Volume is changing. Yes, of course. Are you having outside pressure? No. Therefore, remember, work done is always measured with respect to quantity of 2 parameters. One is called, are you having opposing pressure? Yes, work is available. Are you having change in volume? Yes, work is available. If there is no opposing force, no work is done. Vacuum. In vacuum, if the gas container is expanding, no work is done. That type of work or that type of expansion is called free expansion. What is the meaning of free expansion? Opposing force is 0. If suppose opposing force is 0, what you are trying to do actually, you want to maintain large difference between opposing force and the gas pressure force. It is very good example of irreversible process, because condition is difference in opposing force and driving force. Opposing force, outside pressure. Driving force, inside pressure should be large. Sir, I have made so much large because outside is completely, I made 0. If it is so, it is called free expansion. It is an example of irreversible expansion. Doctors, free expansion is irreversible expansion. Isothermal. Now, what is the now heading? Isothermal free expansion is an example of irreversible. Come on. How to do for that? Sir, work is equal to 0. Achha. By the way, if you are saying work is equal to 0, then do you think that system is absorbing heat energy or not? How to check up? Isothermal. What is the meaning of isothermal? No change of temperature. T2 equals to T1. When T2 is equal to T1, you should understand it. Earlier you have done E2 is equal to E1 because energy depends upon temperature. If E2 is equal to E1, delta E is equal to 0. Now first see this one. Sir, delta E is 0, W is 0. Therefore, definitely Q is 0. That means during free expansion, system is isothermal. There is a conducting vessel. System can take up heat energy, but system says, I am not doing work. Why should I take energy from surrounding? Hence, in case of free expansion, who is 0? Delta P is large enough. Because of that, we are saying irreversible. Next, let P external is equal to 0, right? Expansion in vacuum. What is the meaning of isothermal? Delta E is equal to 0. What is the meaning of work? P external 0 vacuum? Work is 0. If these two are 0, this is 0, this is 0. Therefore, Q is equal to 0. This is a question. Which of the following are correct? Are correct. Multiple answers are correct in case of isothermal free expansion. The question is isothermal free expansion. Then I have to say delta is 0, work is 0, and Q is also equal to 0. This is a question. Come on, next. If it is 0, there is a problem. What is that? Sir, what is delta H? Go back to previous class. What we have said in the previous class, somewhere you have said somewhere here. Sir, delta H is equal to delta E plus P delta V. Delta E plus P delta V is delta H. Right? Work is 0. This is also 0. 0 plus 0. QP is 0. What is the other name of QP? Delta H. Therefore, delta H is also equal to 0. That means all the parameters are 0. Hence, it is a beautiful question to be created, right? But in which case, remember, isothermal free expansion. This is case number 1. Come on. B, isothermal, again I am saying irreversible. Why I am saying one more heading? Sir, here we said pressure difference is too large. For that purpose, roll number 1 said, I want to make outside pressure 0. What he has done? He removed all 50 marbles. Go back to my class. I said, roll number 2, come on, come to me and do the job. What he has done, roll number 2, 50 marbles in the first stroke, 50 marbles in the second stroke. Is it vacuum? No, sir, it is not vacuum. Therefore, such type of processes where you should have P external not equal to 0, P external not equal to 0, but difference in pressure should be large. Yes, it is called irreversible. Remember, P external 0 is not necessarily always irreversible. It is irreversible, but other processes can also be called as irreversible, such as P external is large enough. It is called intermediate expansion. Why it is so? I don't explain now. After some time, when you understand the third column, I'll come back to the word intermediate. Keep it in your mind as a doubt. Next. Delta P is large enough. Why? Irreversible. Understood, sir. Next, let P external is not equal to 0. Right? This is the case over equal to 0. I am creating a new case, not equal to 0. If it is so, then there are two chances. Either P external less than G, or P external more than G. If P external less than G, outside pressure is less. Piston will move up. Expansion. See the heading? Expansion. P external is less than PG. Suppose you want to say, sir, I want to talk about compression. Okay, no problem. P external more than PG. Another heading you can create. Next. Delta E is 0. Why? Isothermal. Okay, got it. Next. P external is not equal to 0. Work done is not equal to 0. Remember, because work done is minus P external delta V. Expansion means delta V is available, change in volume. But you are saying P external 0 earlier, work done was 0. Now it is not equal to 0, therefore there will be some work done. Now if you are doing this work, the question comes, on what basis you are doing work? Answer is very simple, sir. Isothermal means the container is conducting vessel. I'll take energy from outside. I'll take energy from surrounding. Therefore, amount of work done is equal to amount of heat absorbed. As much heat I'll take up from surrounding, that much work I'll do. But remember, what is happening here? Come to this. Delta E is equal to Q plus W. What you said? Delta 0, Q. This W goes that side, becomes minus. Magnitude? Yes. If it is 400, it is also 400. But if it is 400, it is minus 400. If it is minus 400, it is plus 400. Now, suppose, for example, you are saying, sir, it is work positive, compression, heat energy released. Work negative, expansion, heat energy absorbed. That means, in case of isothermal process, if system is absorbing heat energy, work is done by the system. ये minus को यहाँ से उठा के यहाँ लाइए. Plus Q, system is absorbing energy. Minus W, work of expansion. If you understand the sign convention, you can enjoy the beauty of thermodynamics. अब ठीक है sir, delta E 0. क्यों 0? Isothermal process. Work is not equal to 0. Why not equal to 0? Because pressure is not 0. Outside pressure is not 0. Then what is the relation between these two? If this is 0, Q and W both are equal in magnitude, but opposite in sign. Yes. Now, what is delta H? Delta H क्या होगा? Sir, delta H यहाँ देखो नीचे. Delta H is equal to delta E plus W. Delta E 0. बात समझ में आ गई. Delta W not equal to 0. 0 plus not equal to 0 is equal to 0 लिख रहा हूं मैं यहाँ पे. अरे सर क्या बात है, यहाँ पे 0 लिख रहे हैं, यहाँ पे plus 50 लिख रहे हैं, आंसर क्या आ रहा? 0. Yes, remember, mathematically you can't enjoy the game. You have to enjoy the game in a conceptual manner. How it is 0? We'll try to understand that also. Okay, keep the doubt. How it is 0? See here. Before going to that, how it is 0, how to talk about work done is not equal to 0. तो इसका मतलब है there must be some formula for work, some expression for work. What is the expression? Doctors, be careful. Go ahead with respect to systematic understanding. यहाँ लिखने का तरीका देखो. Work irreversible isothermal. Work irreversible isothermal. हर चीज डिफाइन कर रहा हूं मैं. This is a path. This is a path. Irreversible isothermal एक path हो गया. Reversible isothermal और एक path हो गया. फ्री एक्सपेंशन ये भी एक बात है, माइनस पी एक्सटर्नल डेल्टा वी, सर ये हमको मालूम है, माइनस पी एक्सटर्नल डेल्टा वी का मतलब V2 माइनस V1। यहाँ रुकिए आप सर, इन द क्वेश्चन ही हैज गिवन पी एक्सटर्नल, वॉल्यूम फाइनल, वॉल्यूम इनिशियल, फॉर्मूला इज ओवर, यू गॉट द आंसर, सिंपल नर्सरी क्वेश्चन बोल रहा हूं मैं। No, sir, he has not given volume, he has given temperature and pressure. चलो आगे बढ़ो। P external, V2, PV is equal to nRT. PV is equal to nRT. Therefore, V is equal to nRT by P2. Why T2 is not written, sir? Isothermal. Got it? T2 नहीं लिखेंगे, हालांकि क्या होना चाहिए था? nRT2 by P2 minus nRT1 by P1. Yes, you are right. But we should not write T2 T1 because the process is isothermal, temperature remains constant. ठीक है, इसको जरा बाहर निकालिए, माइनस पी एक्सटर्नल nRT 1 by P2 minus 1 by P1. Doctors and engineers, stop here, take a break. In the question, if initial pressure is given to you, final pressure is given to you, and one more external pressure is given to you, 3 pressures हैं, ऐसे problems बहुत 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 कम आते हैं, right? जिससे मैं प्रॉब्लम्स कराता हूं वो बुक में 2 क्वेश्चंस हैं ऐसे, राइट? याद रखना है, P1 इनिशियल प्रेशर, P2 फाइनल प्रेशर, P एक्सटर्नल आउटसाइड प्रेशर. If suppose he has given 3 pressures, go by this formula to find out work done. But remember, फाइनल प्रेशर हमेशा आउटसाइड प्रेशर के बराबर होता है. जरा सोचिए कैसा होगा सर, पिस्टन मूव हो रहा है, क्या मतलब? आउटसाइड प्रेशर इज लेस, इनसाइड प्रेशर इज मोर. Sir, piston is going up, outside pressure is same constant, inside pressure is now volume is increasing, decrease हो रहा है. As it goes on moving, then one time piston comes to rest. अब क्या बोलेंगे? When piston comes to rest, you have to accept, sir, this mechanical equilibrium. It means outside pressure is equal to inside the pressure. इसलिए remember, in 99.5% cases, फाइनल प्रेशर इज एक्सटर्नल प्रेशर. इसलिए फॉर्मूला हम डिसाइड कैसा करें? W इज इक्वल टू माइनस P एक्सटर्नल, क्योंकि वो डिसाइडिंग फैक्टर है. सो P2 इज इक्वल टू P एक्सटर्नल. अगर आप इसको रिप्लेस करेंगे तो ये P2 यहाँ पे आएगा, कैंसिल होगा, 1 बनेगा, माइनस P2 by P1. सपोज ही हैज गिवन ओनली 2 प्रेशर्स, दिस इज द एक्सप्रेशन. 3 pressures, this is the expression. Volume, this is the expression. These are all expressions necessary to find out the amount of work done. That means आपके problems पूरे यहाँ पे solve हो रहे हैं, आपका काम है सिर्फ substitute करना. Okay, चलिए. Now, if suppose you are going further, note. What is that note? H is equal. अब यहाँ मैं I am trying to explain how you can say 0 plus 50 is equal to 0 in thermodynamics. Yes, really enjoy the beauty. ठीक है? We have defined H is equal to E plus PV. If you are saying like this, ये है defined equation. ये कौन है? Enthalpy, internal energy. ये कौन है? Work factor. चलिए अब इसको differentiate कीजिए. DH, general differentiation कर रहा हूं मैं, DE plus D of PV. अलग अलग नहीं किया, D of PV. आप लोग क्या बोलते हैं MPC वाले? सर PDV plus VDP. बिल्कुल सही है, हम उसको अलग नहीं कर रहे हैं, हम स्टेप वाइज कर रहे हैं, राइट? चलिए अब बोलिए, व्हाट इज द फिजिकल मीनिंग ऑफ डी ऑफ पीवी? चेंज इन पीवी. इज इट करेक्ट? अब आइए इधर, आइसोथर्मल. व्हाट इज द मीनिंग ऑफ आइसोथर्मल? पीवी रिमेन्स कांस्टेंट, बॉयल्स लॉ. याद आ रहा है? गैसियस स्टेट, पीवी रिमेन्स कांस्टेंट. अब बोलिए, इफ पीवी इज कांस्टेंट, व्हाट इज चेंज ऑफ कांस्टेंट? सर, 0. Therefore, physical meaning of dPV is equal to 0. Yes, numerical value of work done is not equal to 0, but D of PV is equal to 0. ऐसा करके हम कहते हैं for isothermal processes, yes, PV is constant, D of PV is 0, therefore delta H is equal to 0. जिसको समझ में आ गया, enjoy the gift given by God to you that you have that much enjoyment. If जिसको समझ में नहीं आया, सर ये सब बेकार है, डेल्टा H 0 याद कर लिया, बात खत्म. किसके लिए? आइसोथर्मल प्रोसेस में डेल्टा E 0, डेल्टा H also equal to 0. समझ में आया तो ऐसा जाना, समझ में नहीं आया तो वैसा जाना. हमको होना है 4 मार्क्स. चलिए, राइट? नेक्स्ट. अब आइसोथर्मल रिवर्सिबल एक्सपेंशन, यहाँ पे थोड़ा सा ब्रेक देंगे. कंटेंट ज्यादा हो गया, लिखने में तकलीफ होगी, पहले ये लिख लीजिए, फिर आगे बढ़ेंगे। गो अहेड। Write down equations properly. Don't neglect derivations. ये और बात है कि हमको derivations बाद में काम नहीं आएंगे, एक वक्त नोट्स में सलीके से लिखिए। Zahiruddin, did you understood how the system gets cooled upon expansion? Is that concept clear? आप क्वेश्चन कुछ और पूछ रहे हैं, मैं आपको जो चीज हो गई वो पूछा तो नो बोल रहे हैं। भाई आप किधर हैं? आप पूछे मेरे को क्वेश्चन एडियाबैटिक कंप्रेशन के बारे में, तो मैं आपको बोला एडियाबैटिक एक्सपेंशन समझ में आया, नहीं है समझ में आया? क्या समझाया था वो समझ में आया? एक्सपेंशन में बेटा, एडियाबैटिक एक्सपेंशन में, एडियाबैटिक एक्सपेंशन का जो स्कूलिंग बोला था वो समझ में आया? हाँ, वेरी गुड। तो कंप्रेशन में डाउट है क्या? वेरी गुड, वेरी गुड। Isothermal process P is constant. मोहम्मद खान, बॉयल्स लॉ पढ़े बेटा? बॉयल्स लॉ में बोलो क्या बोलते? व्हाट इज बॉयल्स लॉ? PV is equal to constant. Is it not Boyle's law? Yes or no? हाँ, इसका मतलब है PV is equal to constant, जहां भी आएगा वो थर्मल प्रोसेस को इंडिकेट करेगा। हम पढ़ चुके हैं वो। चलो आगे बढ़ो। C, what is it? C, डेल्टा E इज इक्वल टू W ड्यूरिंग अडियाबैटिक प्रोसेस। इसमें समझाने का क्या है बेटा, इसमें समझाने का क्या है, इक्वेशन देखो ऊपर वाजिद, A इज इक्वल टू B प्लस C बोला मैं, A इज इक्वल टू B प्लस C बोला, B इज इक्वल टू 0। मोनिका, अच्छा సెపరేట్ ఉన్నాయి అవి మంచిది తీసుకుంటారు పెట్టాలి, ఇది ఉండాలి, అది ఐఐటి కోసం తెచ్చారు, మీరు వీటి కోసం కావాలి ఇంటూ 3 నాకు కావద్దంటే సార్ ఏమో లైబ్రరీలో పెట్టుకుందామని చెప్తున్నారు, డిస్కౌంట్ ఎంత ఇస్తారు ఇక్కడ 30%, అమెజాన్ లో 48 వస్తున్నారు, కానీ మనకు అర్జెంట్ రాదు, అది అర్జెంట్
ఆన్లైన్ పెట్టారండి సార్, కానీ 30 years పెట్టారండి సార్, ఇది అయితే మనకి 2020 వరకు వచ్చేస్తారు,
రైట్ పెట్టుకుందాం ఇది ఇది ఫిజిక్స్ కెమిస్ట్రీ మ్యాథ్స్ లేదు, బయాలజీ కూడా ఉంది కదా, రైట్ రైట్ నీట్ కోసం కావాలి, ఎయిమ్స్ పిల్లల కోసం కావాలి అది, రైట్ ఓకే అయిపోయింది, అది వేస్ట్ అయిపోతుంది, ఆయాసపడినా తిన్నారా అని చెప్పి యూజ్ చేసుకొని చెప్పండి, ఇదైన తర్వాత లంచ్ 0, లంచ్ అయిపోయింది ఇప్పుడు, దిస్ ఇస్ లంచ్, అది యూజ్ చేసుకొని చెప్పండి, ఉన్నదా ఇది తీసుకో ఆయన పప్పి అబ్దుల్ వాజిద్, what is the doubt at expansion and compression? Headings doubt है क्या बेटा? Is it over? Shall I proceed? The lunch use చేసుకోండి, ఇది ఓకే నాకు సఫిషియెంట్, లంచ్ యూస్ చేసుకోండి, వేస్ట్ అయిపోతుంది కదా, రైట్. ఇన్ కేస్ ఆఫ్ అడియాబాటిక్ ఎక్స్పాన్షన్ కూలింగ్, in case of adiabatic compression वार्मिंग, आप खाना नहीं खाए काम कर रहे हैं, आपकी एनर्जी कम होगी, आप एक जगह बैठे हुए एक साहब आपकी अच्छी धुलाई कर रहे हैं, आपको गुस्सा आएगा, यही है adiabatic compression, adiabatic expansion। थोड़ा उसको गौर से एग्जाम्पल जहन में रखो, मैं जो दिया कॉमन एग्जाम्पल दे रहा हूँ, घर में जाके बैठ के जब आप नोट्स पढ़ेंगे सोचना, इमेजिन करो, then you can enjoy the meaning of that, ठीक है, चलिए next, shall I proceed? How cooling अब नहीं समझाता बेटा, मोहम्मद खान अब नहीं समझाता, हो गया, बहुत समझाया, अंसार अनस को समझाना है, नहीं समझाता, इतना सिंपल एग्जाम्पल दिया मैं, आप खाना नहीं खा के आए, उसके बाद में आप काम करे तो आपकी एनर्जी कम होगी, पहले एनर्जी 400 थी तो आपका टेम्परेचर था 880 डिग्री सेंटीग्रेड, आप काम करने के बाद एनर्जी कम हुई तो टेम्परेचर क्या होगा, कम होगा, मैं समझता हूँ टेम्परेचर कम हुआ तो लोग कूलिंग बोलते शायद, ठीक है बेटा, प्लीज राइट, इरिटेट मत करो, थोड़ा सा दिमाग भी इस्तेमाल करो, बहुत लो लेवल पर जा रहा हूँ, बहुत लो लेवल पर, बिकॉज आई नो ऑनलाइन में बच्चे आपके कैसे हैं क्या है, इसलिए प्लीज थोड़ा सा इन्वॉल्व होइए, आप भी थोड़ा सा अपना दिमाग इस्तेमाल करो, फिर मजा आएगा, वन वे ट्रैफिक में कुछ भी नहीं होता। Shall I proceed? सिंपल है बेटा, थर्मोडायनामिक सिंपल है, थोड़ा सा टाइम लगता, एकदम एक दिन में ताजमहल थोड़ी बना सकेंगे आप, थोड़ा सा टाइम लगता, उसके लिए एंजाइटी नहीं होना, टेंशन में नहीं होना, कूल रहना, ठीक है, हम पढ़ेंगे फिर पढ़ेंगे, बार बार पढ़ो, समझ में आएगा। इज इट ओवर? अब इसके आगे और थोड़ा कॉन्सेप्ट ट्विस्टिंग में होगा बेटा, जैसे जैसे अब मैं आगे बढ़ूंगा थर्मोडायनामिक्स में, इसकी खूबसूरती और बढ़ेगी। और जाहिर है खूबसूरत चीजों को संभालना जरा मुश्किल होता है, सो थोड़ा हिसाब किताब से संभाल लेना। तो हिसाब किताब से संभालना मतलब डेली पढ़ना। कम ऑन, शैल आई प्रोसीड ओवर? चलिए अब देखिए, a beautiful thing will happen here. What is that? Isothermal reversible expansion. ठीक है, isothermal, sir I know it, temperature is constant, delta is 0. फट से बोलना, isothermal delta is 0, फौरी आपके जुबान पे आना, delta है 0, फौरी आ गया। चलिए, expansion V2 is more than V1, वो भी समझ में आ गया। अब reversible क्या मतलब? Sir, that boy on that example removing one marble at one time, removable one marble one time. Okay, wait a minute. एक मिनट ठहरिए। फाइन, अब क्या होगा? Reversible. Difference in outside pressure, inside pressure is very small. If it is so, then how to proceed? I don't know anything, sir. I know only formula. क्या formula है? Work done is minus P external delta V. Delta V क्या मतलब? Large change. No. I am talking about reversible. Small change. Right? चलिए अब delta P tends to 0. Very good. Then let P external is not equal to 0. ये भी ठीक है। PGP और minus P external delta P tends to 0. ये कंडीशन किसका है? रिवर्सिबल का। यहाँ पे क्या बोले थे आप? Too much large. Delta P is large enough. Here you are saying no. It is very small enough. Right? Next. Kazim sir, are you available in the class? Just give me a message whether you are available in the class. Kazim sir. चलिए टाइम खराब हो। Let P external is not equal to 0, delta P tends to 0. इसका मतलब क्या हुआ? रिवर्सिबल प्रोसेस। अब आइए, डेल्टा E 0, Y आइसोथर्मल, डेल्टा H 0, Y आइसोथर्मल। ठीक है, अब आगे आइए, P external is not equal to 0, इसका मतलब work is not equal to 0. Work done. Once you are having work is not equal to 0, we have to calculate the amount of work done. How to calculate the amount of work done? वही फॉर्मूला है। No, not like this. What is that? Minus P external, delta V नहीं लिख सकते। No, you have to write dV, small change, right? Magnitude of work done is equal to magnitude of heat energy. दोनों का सेम होगा, लेकिन एक पॉजिटिव होगा तो एक नेगेटिव होगा। Amount of work done in isothermal reversible expansion. Amount of work in isothermal reversible expansion is always maximum. क्यों maximum? Right? यहाँ पे हम क्या बोले थे कि if suppose you are supplying heat energy, go back to yesterday's class, it is used in two jobs. Number one, increase the energy. Number two, work of expansion. अब यहाँ पे increase of energy 0 है। If increase of energy is 0, इसका मतलब जो भी energy system लेगा, that whole energy is useful in case of work done. Whole energy is useful in case of work done. Therefore, work done is maximum in case of isothermal reversible expansion, right? यहाँ पे क्या बोल रहा हूं मैं? Maximum. और एक जगह 0 बोला था, याद है? In case of free expansion I said 0. यहाँ 0 है केस A में, और यहाँ 2 में लिखा हुआ है मैक्सिमम, 0 मैक्सिमम, इसलिए केस बी को हम नाम दिए इंटरमीडिएट एक्सपेंशन। बात समझ में आ रही है? यहाँ है इंटरनली, इट इज सपोज्ड टू बी समथिंग लाइक दिस। व्हाट वी आर टॉकिंग अबाउट? जीरो वर्क, फ्री एक्सपेंशन। नो सर, हियर वी हैव मैक्सिमम वर्क। दोनों के बीच के जो रहेगा उसको बोलेंगे हम इंटरमीडिएट वर्क। टेक डाउन दिस मच, उसके बाद स्लाइड चेंज करेंगे। Kazim sir, are you available in the class? If it is so, please give me a message. Put a message there in the box. Go ahead, go ahead. Is it over? Go ahead, go ahead. Shall I proceed? Okay, no. Very good. Come on. What is our isothermal irreversible, isothermal reversible? But the formula for reversible, we have to get that one. Okay, go ahead. This is the formula. What is work reversible isothermal? Minus P. Don't see that sign, integration sign. Doctors, integration sign. Right? S को थोड़ा सा लंबा खींचना ऊपर से नीचे से तो इंटीग्रेशन साइन बनता है. Minus P external dV, small change. Reversible isothermal minus integration of P external. अब सर ये इंटीग्रेशन क्या बोला है? कुछ भी नहीं है, सिंपल है. अगर आपके पास स्टेप वाइज प्रोसेस हो रहा है, 10 स्टेप है, 20 स्टेप है, 20 स्टेप्स, 30 स्टेप्स, A plus B plus C plus D plus ऐसे चलिए. Irreversible process में total work is equal to W1 plus W2 plus W3. If it is infinite number of steps, then mathematically people say integrates within the limits. हम यहाँ limits नहीं लगा रहे हैं, limits लगा के करना है because it is by BC combined. I am not using limits. NPC वाले you can enjoy the limits if you have done integration, right? So integration of P external dV. ठीक है सर. W reversible isothermal minus P external gas. Sir, typing mistake है शायद. No. Remember, in case of isothermal reversible process, what you have said, at every time there is an equilibrium. Outside pressure, inside pressure. Outside pressure, inside pressure. Always they are equal. It is same value. Therefore, इसको हम इससे replace कर सकते हैं. This is not correct in case of irreversible process. ये concept है. समझ में आया? Very good. समझ में नहीं आया? सर हमको derivation नहीं चाहिए, हमको चाहिए final formula. Right? Enjoy in both the ways. No problem. Right? Minus PV is equal to nRT by V dV. Minus nRT को बाहर लाया मैं because they are constant. Integration of 1 by V dV. Right? Integration of 1 by x dx log x. Yes. Work reversal isothermal is equal to minus number of moles, gas constant, absolute temperature, natural log. ln का मतलब natural log. ये writing में आपको शायद in दिख रहा है, ये ln है. ln V2 final volume, V1 initial volume. ये है formula. आपको याद रखना है ये expression. ठीक है? इसको हम ऐसा भी लिखते हैं. ये ln है, ये log है. log का मतलब है log to the base 10, right? ln का मतलब है log to the base e, right? Exponential minus. How to convert natural log to common log? इसको कहते हैं natural log. इस वास्ते ln लिखते लोग. Base e रहा तो log e लिखे तो इसको बोलेंगे natural log. Log 10 लिखे, 10 नहीं लिखते usually common log. How to convert natural log to common log? Multiply by 2.303. अब यहाँ पे minus 2.303 nRT log V2 by V1. No sir, volume and pressure are inversely proportional in case of isothermal process. ठीक है, minus 2.303 by RT log P1 by P2. In an isothermal expansion, as number of steps increases, amount of burden also increases. Statement 4 marks का question है. In an isothermal expansion, as number of steps increases, amount of burden also increases. यहाँ तक आज का काम है. इसके बाद कल करेंगे. लिख लीजिए. कुछ भी नहीं है बेटा, कुछ भी नहीं है। ln और log में कुछ भी समझना नहीं है। एम्स के बच्चे आप और टेंशन में आएंगे, मैं समझाया तो समझना कुछ भी नहीं है। ये याद रखना, ये याद रखो खाली बस। 2.3 लॉग वैल्यू देखना या जो भी है, सपोज v2/v1 5 आया, लॉग 5 देख लो, खत्म, ऐसा। ठीक है, इसमें समझने का कुछ भी नहीं है, आपको याद रखने का सिर्फ LOG है। ठीक है, ज्यादा टेंशन मत लो ये चीजों में। आपको जो चीज होना है वो पकड़ लो। आपको क्या चाहिए सर? फॉर्मूला चाहिए, ले लो। उसके बाद का स्टेटमेंट वेरी इंपॉर्टेंट, ले लो। डेरिवेशन पार्ट में टेंशन मत लीजिए, अननेसेसरी डोंट वेस्ट योर एनर्जी। जहां जरूरत है फुल एनर्जी यूज करो, जहां जरूरत नहीं है छोड़ दो उसको। नाइस, वेरी गुड। श्रीनिवास, थैंक यू वेरी मच। లంచ్ నాకు చేసుకున్నాను, రైట్? లంచ్ యూస్ చేసుకోండి, ఎవరన్నా యూస్ చేసుకోండి, వేస్ట్ అవుతుంది.